Welcome to First Take Math with Brian Thomas.
This lesson will be on multiplying polynomials, and we're going to use something we've used in earlier lessons called the rectangular model. So remember, in multiplication, to find the area of a rectangle, all we have to do is multiply the length and width together, and that'll tell us the area of a rectangle. So the area of a rectangle is essentially a multiplication problem. Now, if we want to take this one step further, let's look at the example 19 times 49. A way to look at this, if we want to be creative, is 19 is really the same thing as 20 take away a 1. And 49 is really the same thing as 50 take away a 1. So instead of using 19 times 49, I can use these expressions. So instead of using a 19 and a 49, I can partition this into 4 little regions. A 20 and a negative 1, and a 50 and a negative 1. So I can partition this into 4 regions. And what this becomes is 4 multiplication problems, and then to get our answer we have to add all this together. So 20 times 50, define this area. We know that that's simply 2 times 5 is 10 and add 2 zeros. That's going to be 1,000. 20 times negative 1 is a negative 20. We know a negative 1 times 50 is a negative 50. And then a negative 1 times that negative 1 would be a positive 1. So put this all together. Well, 1,000 take away 50 would be 950. 950 take away 20 would be 930. 930 plus 1 would be 931. So that would be another way to do that multiplication problem, is using the rectangular model. Now again, if I just want the answer, calculator 19 times 49, hopefully that will give us our 931. But your calculator really doesn't do this problem, but the rectangular model can. So let's model this using our rectangular model. So I got a multiplication problem because the parentheses are next to each other. So this piece is multiplied to this piece. So this represents one edge of the rectangle. So I'm going to put an x and a 3 on this edge. And then this x plus 5 represents the other edge of the rectangle. So I have an x and a 5 this way. And that's going to partition the rectangle into 4 regions. Well, we know that x times x is repeated multiplication, and we can use exponents to simplify that as x squared. We know x times 5 is 5x. There's nothing else we can do with that. 3 times x is 3x. That's all we can do there with that. And then this 3 goes to this 5. 3 times 5 is going to give us our 15. Now we just put this all together. But really the only like terms are these two guys right here. They go together. So if I put this all together, we should see then we have x squared, and then 3x's and 5 more x's gives me 8x. And then we have a 15 there on the end. So those are all added together to give us our answer. So this is as far as that goes because these pieces cannot be put together. Let's look at this next example. So we have the quantity of x minus 3 times the quantity of x minus 10. So again, we can do this using a rectangular model. Let's see, make a rectangle. So x minus 3 means we can kind of bring the x and the negative 3 down this way. They're the edge of one side of the rectangle. And this x minus 10 represents the other edge of the rectangle. So x negative 10 goes along this way, which allows me to partition the rectangle into 4 regions. So again, if we multiply to get this piece, x times x is really the same thing as x squared. Negative 10 times x is just negative 10 times x, or negative 10x. Negative 3 times x is negative 3x. And remember, we like to put that number in front of the variable on these. We don't like to have that as x negative 3. We like that as negative 3 times x. So always keep that number in front, and we call that its coefficient. Negative 3 times negative 10 would be then a positive 30. And again, if you notice, these guys again are like terms. They can be put together. So if we put this all together, adding it all up, we see that x squared, we get a negative 13x because of these two pieces. And then we have a plus 30. And that would be our answer to this problem if we multiply it out. So again, if you have a problem that looks like this, we are allowed to use a rectangular model to multiply that out. So let's look at x plus 5 times x minus 5 times x plus 9. Again, I'm going to try to sneak in a rectangular model over here. Notice again how I'm doing it off to the side there. It's kind of like scratch work. So the x in the negative 5 becomes one edge. The x in the positive 9 become the other edge. I then partition this off into 4 regions. X times x is x squared. 9 times x is just 9 times x. Negative 5 times x is just negative 5 times x. And negative 5 times 9 is a negative 45. And again, notice that these guys can go together. So now I have x squared, and if you have 9 positive x's and 5 negative x's, these guys are going to knock out 5 of his, so you should have a positive 4x there. And then a minus 45 on the end. And again, that's as far as that goes. These would not be like terms. This last expression, notice how we have this exponent of 2 here. Well, that means we have 2 of these. So x minus 6 squared means we have x minus 6 times x minus 6. This now should look familiar. We can use the rectangular model to work this out. So the x to negative 6 is one edge, and the x to negative 6 is the other edge. So I probably should have drew a square. Since these dimensions are the same, that should look more like a square. So x times x, we get our x squared. Negative 6 times x is negative 6x. Negative 6 times x is negative 6x. And negative 6 times negative 6 is a positive 36. Again, you will notice that these two terms are, again, alike. They can be combined to make one term. So in the end, we have, as our answer, x squared and 6 negative x's and 6 more negative x's gives me a total of 12 negative x's. And then we have a 36 on the end. So that's just all put together into that. So again, what we're seeing is we have a binomial times a binomial, and that creates what we call a trinomial. A binomial times a binomial, 2 terms by 2 terms, creates a 3-term expression, which we call a trinomial. So hopefully you'll find this useful to multiply out expressions that look like this.